Let's figure out why drones are needed for this hack in the first place. Drones can quickly go where people cannot. Say there's a well-secured perimeter. A drone can pass through any of the defenses meant to keep people out. It can fly up to any floor of a building quickly and often without detection. Drones are small, so they can even fly into an open window and wreak havoc on computer systems in the blink of an eye. But what kind of wireless technology would enable a drone to do so much damage without running out of battery? Well, there are some zero-click attacks which take just a few seconds. This means that the drone won't need to pause its flight, the attack can be performed on the go. There's one well-known, extremely widespread vulnerability built into hundreds of thousands of wireless mouses and keyboards that can be taken advantage of in just 1 to 2 seconds, with maximum effect, giving hackers wireless access to a PC, and it's called Mousejack. Imagine you're sitting at home, or working at an office on one of the top floors of a building, or deep inside some highly secure facility a few hundred meters away from a checkpoint. You'd think you're completely safe from hackers, yet here comes a drone, hovering just outside your window. You might notice it, or you might not. Either way, the drone will install malware onto your computer in just seconds. You're unlikely to notice any changes to your computer, and even if you see that backdoor installer that comes up for a second, you're probably not going to think that it has anything to do with the drone that just flew by. And if you're not at home and instead, say, at some office building, then the hacker can find their way into the internal network. Just a few minutes after a successful attack, the bad guys can test several different exploits on the main servers of your company. It's quite likely that your company's internal infrastructure will be compromised before the security team can even get their eyes on the breach. The attack seems like something out of a hacking-themed movie or video game where the drone completes the attack in just seconds. The vulnerability here is that there's a large number of wireless adapters for things like mouses and keyboards, and they use a separate radio channel that doesn't check the sources of the signals that come its way. Unlike Bluetooth, these devices aren't standardized. Producers on the wireless market don't always develop their own devices, and instead use various chips. And the vulnerability here is a chip called NRF24L, which has an unsafe wireless radio interface. The chip turns out to be highly popular and is used by a lot of producers, including Dell, Logitech, Microsoft, HP, Amazon, Gigabyte, and Lenovo. And it's really difficult to pin down exactly how many devices use this chip. This list contains just a few of the devices that have this vulnerability. Physically, what happens is the radio channel on the NRF24L chip uses the same frequencies as Bluetooth and Wi-Fi, but uses only 83 frequencies that are 1 MHz in width, which therefore covers everything between 2400 and 2483 MHz. What happens on a software level is that every wireless device has its own MAC address. All these devices work in a star or spoke hub network. There are some devices, like a mouse or keyboard, in this network, the nodes. And there's a USB adapter in the middle, which is like a central switch. This way, each device is connected directly to the switch. However, they are not connected to each other. So, the switch is the server and the devices are the clients. Therefore, the clients, or devices, send information about things like movements of the cursor or keyboard inputs, and the USB adapter tells them whether the signal was received. This essentially creates a one-way transmission. In our case, the adapter is connected to a mouse and keyboard. For a real-world attack, the hacker needs to figure out and forge the needed radio signal. The adapter doesn't broadcast any signal packs, even if they've just been connected, and therefore it's impossible to determine if there aren't any working mouses or keyboards. Every device widely transmits signal packages to the network with a unique MAC address. The adapters only pick up signals from their own sub-networks. The attack doesn't target the MAC address of the adapter, but instead those of the connected devices. So, for the attack to work, there needs to be a mouse or keyboard connected. In reality, the vulnerability isn't quite the mouse or the keyboard themselves, but rather their wireless adapters. Picking up the signal from a connected mouse or keyboard, which contains the MAC address, hackers can forge the signal using the intercepted MAC address as the source. A vulnerable wireless adapter won't be able to tell the hacker's signal apart from a legit signal, and will enable the keyboard inputs sent over the compromised radio signal. It's worth noting an interesting and dangerous fact. An adapter from a wireless mouse can pick up wireless keyboard inputs. The OS in a mouse and keyboard use related HID devices. The attack works by forging wireless mouse or keyboard signals to send inputs to the victim computer, which, if executed, give hackers access to that computer. In fact, these exact keyboard inputs can be executed at an extremely high rate of speed, 1,000 inputs per minute. However, for a successful attack, about 40 to 50 inputs is enough. In other words, all that's needed is a few seconds.